On this video, we're going to talk about the product rule. So if your page at the top of page 50 has the word product highlighted, this is the correct video you should be watching and taking notes. If it says quotient, if the quotient is highlighted, you should be watching the other video. Okay, so the target for today is students will learn and apply the product rule to complex functions to find the derivative of a function so that they can calculate that instantaneous rate of change. So remember, the whole point of finding the derivative is to calculate the slope at a specific point. So our derivatives are those unique slope formulas to the function we're actually deriving. We kind of never want to lose focus of that. Okay, so if we have a product, so I'm going to go to page 50. If we have a product of two functions, we can either do one of two things. We can simplify it to where it's no longer a product, or we can use what we call the product rule. Okay, so the product rule says the derivative of f times g is the derivative of the first function times the second function plus the derivative of the second function times the first function. So derivative of the first times the second plus derivative of the second times the first. Now, the order that we put them in, because we're adding, doesn't really matter. The one thing that you want to make sure that you know is that two derivatives never go together here. So one is function, one is derivative when we're multiplying. So for example, if we want to find the derivative of h of x of equal to this function right here, in class we've been simplifying that function to actually find the derivative. So we can actually take this function and simplify it first. So I'm going to come up here. By distribution. Okay, so that's one way we can actually take the derivative. But because this is a product, that idea of times being the operation that's going on, we can apply the product rule and just take the derivative as is. So for example, if we consider this to be our first function, that first set of parentheses, and the 5 plus 4x our second function, the product rule says to take the derivative, all we have to do is take the derivative of the first. So let's use our power rule. So 3 minus 4x, derivative of the first, times the second, as is, plus derivative of the second, which just happens to be 4, because that 5 goes to 0, times the first. And we've taken the derivative. Now all that's left to do is actually just simplify this derivative. So I'm just going to distribute and combine my like terms. So I'm going to get 15 plus 12x minus 20x minus 16x squared for the distribution of the first two terms, plus 12x minus 8x squared, distribution of the 4. And then after that, all I'm going to do is combine my like terms. So I have a negative 16x squared and a negative 8x squared, so that's going to become negative 24x squared. Okay. That 20x, or that 12x minus 20x would give us negative 8, plus 12 would give us 4. And then, of course, that positive 15. So as I'm going through and I'm combining my terms, I'm just kind of scratching them out so that I can ensure that I've picked up all of the terms necessary. So there is, in fact, our derivative. We could have always simplified and distributed first, taken the derivative second, as we're used to doing. This is one of those functions we're able to do that. But we have functions that we're not able to simplify through through distribution to get rid of the product. For instance, this idea of x times sine of x. We can't actually simplify that down. So the only way we can take the derivative is to apply that derivative or that product rule. So x is the first, sine of x is the second. So my derivative, f prime of x, says to take the derivative of the first, which is 1 times the second, plus derivative of the second, which we know the derivative of sine is cosine, times the first. Simplifying it really quick, 1 times sine of x is just sine of x. I'm going to drop that 1. And then here's always a thing we want to do. Anytime we're taking a transcendental function like cosine of x here, and we're multiplying it by something, we want to always make sure that we come back and we put that something in the front. That way we don't make the mistake of combining things that can't be combined. And what I mean by that is a lot of times I'll have students that take that and rewrite it as cosine x squared, which is not true because now we've changed what comes behind the trig. And what comes behind the trig stays behind the trig. We don't want to ever change that without the use of a trig identity. I don't know what that was just doing right there. I have no idea where that came from. Let's see if I can erase again. I don't know what that is. Okay, so we're just going to leave it, ignore it. Okay, so next one, e to the x times x. Again, there's not much we can do with that. So the only way to get the derivative is in fact to use that product rule. So our e to the x is our first, our x is our second. So product rule says to take the derivative of the first times the second plus derivative of the second times the first. And then all I'm going to do is simplify this out. Again, I always like my transcendental functions at the end so I don't make some algebraic mistakes with them. So I'm always going to put that x in front just like I did with the cosine a minute ago. Now 2 on the bottom. Okay. Now 2x times cosine of x minus 2 sine of x. So I'm going to use a couple of my derivative rules here. One, of course, that product rule that I just mentioned above, because 2x times cosine of x. That word times implies product, which means I'm going to have to use my product rule. So here's going to be my first, and here's going to be my second. And then we have that minus 2 sine of x. I don't need the product rule for that. It's not really necessary. I mean, if I did, because it is 2 times sine of x, if I did do the product rule there, it would come out to be the exact same thing. But it's kind of unnecessary work since 2 is just a basic coefficient. So I'm going to use that product rule on that first term right there. So h prime of x equals derivative of the first gives us 2 times the second minus derivative of the second, which we know to be negative, so negative sine of x times 2x. So derivative of the first times the second plus derivative of the second times the first. I was going to go back and make sure I got all the pieces. And then I'm just going to bring down that minus 2 from here to that. That's where that 2 is coming from. And the derivative of sine of x gives us cosine of x. So now what I'm going to do is just kind of simplify it, get rid of some of these parentheses, just kind of clean it up really quickly. So that 2 cosine of x can't really be, anything can't be done with it. That plus minus, so I'm just going to turn it to minus sine of x. Actually, I'm not going to do that. I'm going to move that 2x in front. Again, I like my transcendental functions at the end so I don't make some algebraic mistakes and try to combine things that shouldn't be combined. So minus 2 cosine of x. And if we think about it, this negative 2 cosine of x and this 2 cosine of x kind of cancel each other out. So really all we're dealing with is minus or negative 2x sine x. And there's in fact our derivative. Okay, so things canceled out, nice, and made it a little bit more simplistic to deal with. Okay, and then the last example, I'm going to have this be my first, this be my second. Because if I read that, it says k of x is equal to x squared times natural log of x. Times, anytime I say times when writing, that implies product. That might be something to write down on the side. Anytime I say the word times, that implies a product rule must be done. Okay, so I'm going to just do my product rule. So k prime of x equals derivative of the first gives me 2x times the second plus derivative of the second. We learned on Friday or this weekend that the derivative of the natural log of x is in fact 1 over x. So derivative of the second times the first. And then after this, like I said before, it's just a matter of cleaning up. So that's what exactly I'm going to do. So 2x natural log of x, we're going to leave that. But that 1x times the x squared simplifies down to just x. Because remember, if we put it over 1 and we multiply across, we get that x squared over x, which reduces down to x. So one of those cancels out one of those. Okay, so that's kind of the product rule simplistic. Derivative of the first times the second plus derivative of the second times the first. So if you have any questions, please let me know.